Welcome to clickmyproject.com.
Design and simulation of photovoltaic supersystem using Simulink. Solar photovoltaic systems are widely known for their ability to generate electric power for homes and commercial buildings through the absorption of energy from the sun's rays. In the movement towards increased sustainability, cleaner energy and lower utility bills, they are become a more common sight, especially in regions of the country where the sunlight is strongest. However, there are still misunderstandings among buildings and design professionals, not to mention their customers, about the finer details of the PV system. Before specifying or installing a PV system, building and design professionals should have a solid understanding of this system and how they function. We design and simulate the photovoltaic super system using the Simulink. Simulink model consists of PV array, maximum power point tracker (MPPT), battery charger, DC to DC converter, switch control and load. We simulate the photovoltaic system under two different scenarios like sunny and cloud condition with constant load. To convert the irradiance data and temperature into voltage and current, we use two level S function. The simulation is very useful for determining what types of PV modules, batteries and loads can be successfully combined. This is the flow of our project. Consists of 6 model PV array and MPPT design and DC to DC converter, switch control, battery, load and performance evaluation. PV array and MPPT design. The maximum power point tracker is necessary to draw the maximum amount of power from the PV module. We choose perturb and observe algorithm. Basically, the module voltage is perturbed by a small increment and the resulting change in power is observed. If the change in power is positive, the voltage is adjusted by same increment and the power is again observed. This continues until the changes in power is negative, and at which point the direction of the change in voltage is reversed. The next is DC to DC converter. A DC to DC converter is used to increase the efficiency of the system by matching the voltage supply to the voltage required by the load. A DC to DC converter can either step up or step down or both increase and decrease the voltage. The DC to DC converter used by the system is incredibly simple and can either increase or decrease the voltage. The most basic DC to DC converter is based on the idea that power is conserved while altering the voltage and current. Next one is switch control. It is necessary to control whether the switch is open or closed based on the measurable parameters in the system. Each switch has its own operating condition to govern which state it should be in. The switch control in this model is used in conjunction with the charger, shunt and DC to DC converter. The next model is battery. The battery model was based on a lead acid based battery space model. Lead acid battery cells consist of two plates, positive and negative, immersed in a dilute sulfuric acid solution. The positive plate or anode is made up of lead dioxide and the negative plate or cathode is made of lead. The battery model has two modes of operation, charge and discharge. The battery is in charge mode when the current into the battery is positive and the discharge mode when the current is negative. The next block is load. To begin with, a single resistor was used to represent the load. Its resistance is found by assuming it to be a 4000 watt-hour per day load. At 12 volt and keeping the load constant over a full day 24 hours, the resistance can be found to be 8.64 ohms. Keeping the load is simple in principle, but varying the current usage throughout the day, it can be modeled with several varying resistors and accompanying switches that turn and off at predetermined times. The next we calculate the performance evaluation. We run the simulation for both sunny and cloudy day scenarios, input temperature and irradiance data for both the load cases mentioned, giving a total of 24-hour simulation. We simulate the following simulation cases: sunny day conditions and constant load resistance, and cloudy conditions with constant load resistance. Each of the simulation we will use 14401 minute per time steps. For each simulation, the results for the battery current, voltage and state of charge will be plotted, as well as load current, PV array output current and shunt current. All of the current results will be plotted on one graph for each simulation so that the relationship between them can be easily seen. Open the source code folder and run main.mdl file. The simulation model is developed and the battery DC to DC converter switching control is also developed. We simulate the Simulink model for two different kinds of different simulations, like sunny condition with constant load and cloud condition with constant load. Simulation results show that our proposed method gives the better performance to design the PV module for the real-time application. Thank you.